Alright, well look at this. I tried to draw this the best I could. It's a little bit messy, but it's not too bad. So let's see what we're trying to do here. It says, it gives you the graphs of the equation, which I've given already, put them in the right colors and that kind of thing. It says k is a constant. It says if the length of AB is an integer. Now that's very, very important right here. So from A to B is an integer. So let's take a look at that for a second. If it's an integer, it can't be a fraction, can't be a decimal, can't be the square root of something that doesn't come out even, all right? So it's got to be an integer. And it's a length, so I guess it would be a positive integer as well. It doesn't say positive integer, but it should be an integer. So if you look at this, look from A to B. Where is it? They tell you this is the origin, which is 0, 0. All right, so this is 0 some point right here. All right, and as far as going up and down, it doesn't even matter if that's an integer or not. But the length of AB is. So watch, from B, whatever this point is right here. Okay, whatever that X point is. Let's make that a different color. Let's make that white. Okay, whatever this X point is right here, this has to be an integer because X minus 0 is going to be X. And AB has to be an integer, so this has to be an integer. So X has to be an integer. All right, so that's what we have to think about right here. So what we're going to do is look at what do these equations even have to do with each other? Well, this point right here, in order to actually solve for X, to find what X is equal to, this is where they both intersect each other. So if they both intersect each other, what we do is we take these two equations and we set them equal to each other, because that's where they're both equal. So this parabola and this parabola right here have the same point. They share the same point right here. So the same exact x and y point must be shared by the yellow one and the blue one at that particular point right here. And it's also true about here, but we're just concerned about AB. So right here, they must share the same exact point. So the x and the y have to be exactly the same in both of these equations at that particular point right here. So what we're going to do is we're going to take these two equations and we're going to set them equal to each other. So hopefully, now you can go back to that and look at that picture again, but I just have to scroll down and give myself some room here. What we're going to do is we're going to set, let's write the equations down again. So it's y equals x squared and y equals k minus x squared. Okay. So now what we're going to do is we are going to try to solve for x. Right? So watch, if this is equal to y and this is equal to the y, they're equal to each other because remember they share the same x and y. So this y and this y are the same, so that means x squared must equal this thing right here. So I'm going to set them both equal to each other. So the x squared equal to k minus x squared. K minus x squared. And what are we trying to do? We're trying to find what x is equal to tell you the truth. And what they do is they give you, I forgot to write this in here, it says which of the following cannot be a value of k, and I should have written that in here, sorry about that. So we've got A, B, C, D, E, A, B, C, D, E. What we have to do is we've got to try some of these numbers and see which one cannot be a value for k. So we're actually going to get k by itself. So let's get k by itself. So what am I going to do? I'm going to add an x squared to both sides. So if I do that, I get a 2x squared is equal to k. So what we're finding, we're trying to find what k cannot equal. Right? And they give you 5 different values. They get 2, they have 8, that's 12, 18, and 32. So what we want to find, which one can k not equal? Okay, it can't equal k. Which one of these cannot equal what k is? So what are we going to do? We're going to put some numbers in here and find out what x is equal to. Now remember, what x has to be an integer. That's the key to this, right? X has to be an integer. So x could be all kinds of different numbers depending on what k is, but remember, x has to be an integer, which means it cannot be a decimal. You can't take the square, it can't be like a square root of a number that doesn't come out even. Alright, so let's just try some numbers and put some numbers in. Remember, we're pretending these are our values of k. So probably 4 of these work and one of them doesn't work because it says which one, or which of the following cannot be a value of k. So 4 of these they can be a value of k, and then one of them cannot be. That's supposed to be a k right there. So let's just start with the first one. Put a 2 in for the k. So watch, I've got 2x squared equals 2. Let's find out what x would be if k was actually equal to 2. So what I do is I divide both sides by 2. So x squared equals, that's supposed to be squared, x squared equals 1 whenever I divide both sides by 2. So x would equal plus or minus, take the square root of both sides, x would equal plus or minus the square root of 1, which is 1. Now, what is 1 and negative 1? 1 is an integer. So k can be equal to 2. So sure, k can equal 2 if we wanted it to. That would make x into an integer. All right, let's try 8. Let's just keep going until we find one that doesn't work. So we're going to use this little equation right here. So let's put 8 in for the k here. So I've got 2x squared again is equal to 8. Divide both sides by 2, so x squared is 4. Can I take the square root of 4 and it come out to an integer number? Yeah, absolutely. Take the square root of both sides, I get plus or minus 2, so 8 works. That's perfectly fine. Let's try it again with the next one. Just do the same exact thing with 12. Keep going until we find one that doesn't work. And then we don't have to try them all. And as soon as you get that first one that doesn't work, then you're done. So let's try 12. So I've got 2x squared equals 12 for k. See what I'm doing? I'm just putting these numbers in for k, finding what x could equal. Divide both sides by 2, so x squared equals 6. Take the square root. Now look, if I take the square root of 6, it doesn't come out to an integer number. It's just plus or minus the square root of 6. It doesn't come out to an integer. So can k be equal to 12? No, it can't, because my x value would be a non-integer number. So we cannot use that. So the question says, which of the following cannot be equal to k? Well, 12 cannot be equal to k. So k cannot equal 12. Why can't it equal 12? Because it gave us an x value that came out to a non-integer number. Remember, x has to be a non-integer number. This number, AB, has to be an integer. So this value, all right, that x, y value, I don't even care about the y because I'm looking at just AB right here because the y's are going to be 0 anyway. So the x value for this has to be an integer number. All right, and so if you come back down here again, x is not an integer right here. That is not an integer. It doesn't come out to a nice even number. It comes out to some decimal. It's like 2 point something. And there you go. That's it. So hopefully that makes a little bit more sense to you.